Hello everyone, this session I will discuss the one more example of the agglomerative clustering. Here problem statement is given. Use single and complete link agglomerative clustering to group the data described by the following distance matrix. Also in the problem statement it is given that show the dendrograms. Right, so this is my distance matrix given in the problem statement. So there are total 4 objects A, B, C, D, right? And the distance between these objects are given. For example, distance between object A and B is 1, distance between object A, C 4, distance between object A, D 5, and so on, right? So here, first we will discuss the single linkage agglomerative clustering to solve this problem. And in the next session, I will discuss the solution for the complete link agglomerative clustering. Right? So here we know that what is agglomerative clustering. So in the agglomerative clustering, initially every point in the cluster of its own. In the agglomerative clustering, every point is a cluster on its own, and we merge cluster until we end up with the one unique cluster containing all the points. Right, so here we start with the each and every point as a one cluster, and we end up when all the points comes into the single cluster, right? And what is single linkage clustering here? So distance between the two cluster is the shortest distance between a pair of elements from the two cluster. So actually we apply this single linkage criteria to merge the true cluster in every iteration. Right, so here we consider the minimum distance, shortest distance between the two pair of elements. So here is the solution we will discuss here. So when we apply the merging criteria, here we are discussing for the single linkage, we consider the two parameters, D, that is distance, and K means number of clusters. Right, so in every iteration, we find the different set of clusters here. So in the first cluster, right, this solution we will discuss here with the help of dendrogram. So parallelly we will also draw the dendrogram for the each and every step that we are discussing for obtaining the solution using single linkage clustering, right? So initially my distance is 0, right? So this in the merging criteria also we consider the D here. Initially my value of K, that is number of cluster, is equal to 4. Why it is 4? Because my number of data points are 4 here, A, B, C, D, right? And these are the clusters. Capital K is representing here the set of clusters. So my initially my all the single objects are in the single cluster, right? So there are total four clusters. So we start with each point equal to cluster. In the dendrogram also you can show this individual point as a single cluster here. Right? Now next, in the first iteration, my D of value will increment by 1. So now my D is 1 here. And here we will obtain the new set of clusters. So how we will obtain here new set of cluster? By applying some merging criteria, right? So here we check for the minimum distance. So by referring this distance matrix here, right, we find which two clusters we can merge together. So check for the distances between all these objects. So here the distance between object A and B is 1. The distance between object A and C is 4. Distance between object A and D is 5. Here between B and C is 2. Then between B and D is 6. And between C and D is 3. So which is the minimum distance? So definitely here my minimum distance is A and B. Right? So merge A and B since A and B are the closest object here or closest clusters. Right? So distance between A and B is 1. So this distance between these two clusters should be less than equal to this D. So here it should be minimum, and this minimum distance should be less than this D. So which is satisfying my criteria here, right? And that's why in this iteration, we can merge A and B together. So here in this iteration, we have obtained this 3 cluster, new set of cluster, right? So that's why my value of K is now 3. right? In the dendrogram also you can show this link, right? So here A and B we have linked together, means merged together, and C and D is as it is at this point, right? Now next iteration, we check for the minimum distance between the clusters. So now check the distance between the cluster AB, cluster C, and cluster D. So what is the different distance between the cluster A, B, and C? So check for the AC distance and BC distance, and the minimum distance between these two sets will be the distance between these clusters. So the distance between AB is AC is 4, and distance between here BC is 2. So the minimum distance is 2 here, right? So here and also you check for the distance between C and D. So distance between C and D is 3 here. So which is not less than equal to this 2. But the distance between here B and C object is less than equal to 2. So it is satisfying my criteria. So we can merge here A, B cluster with the C, not with the D. Right? So we have obtained here new set of cluster, which is A, B, C, and one more is D here. Right? So this here we are merging A, B, and C, since B and C are the closest, that is this distance between B and C is less than equal to this 2, that is D. Right? So we have obtained here this new set of cluster. And also in the dendrogram, you can merge this AB and C together, right, to show the hierarchy here, right? So we have obtained this one cluster here, new cluster in the second iteration, and D is now single point cluster here, right? Now in the next iteration, right, my D is become 3 here, it will increment by 1, right? Now find out the new set of cluster. Now check whether we can merge this ABC cluster with the D cluster. So how you will check this? Find out the distance between AD, BD, and CD, and check for the minimum distance. So minimum distance is what? Between the C and D is 3 here. The minimum distance is CD 3, and which is less than equal to 3. Which is less than equal to 3 means is equal to 3. So we can, it is satisfying my merging criteria, and that's why we can merge this ABC with D. So we have obtained here one single cluster, right? So we can merge here D with this ABC, and we have obtained the single cluster, and that's why my K has become 1 here. Right? Now my solution will stop here because we have obtained here all the points into the single cluster. I hope students you are clear with this. Also on the dendrogram, you can show these links, right? Because it is a graphical representation of the process of clustering, right? So here we have merged all the objects together, means ABC cluster with the D, because it is satisfying the criteria of merging the cluster using single linkage here. I hope you are clear with this. Thank you. Now the complete linkage solution we will discuss in the next session. Thank you.